In this math talk, we're going to look at how to compare two fractions. And I begin with the question, which fraction is greater, 3/4 or 5/6? Now, before we even get started on that, I'm going to look at comparing two other rational numbers that are written in decimal form. So let's look at 3 to 5.843 and 3 to 5.857. In this form, it's pretty easy to compare and state which number is greater than the other. And it goes like this. We look from left to right at the digits, and we look until we find a difference between the two digits. So they both start with 3, 2, and 5, 3, 2, and 5. So up to that point, you don't see a difference in the numbers. After the first, or at the first decimal place, you see an 8, and then all of a sudden, now we see a difference. We look at the 4, we look at the 5, and with 4 being smaller than the 5, we say that 325.843 is less than the 325.857. And so it's pretty quick and pretty easy to identify based on a difference in a digit, that digit being smaller than this digit, so that we can say that this number is less than this number. It gets a little trickier with two fractions. So when we're looking at 3 over 4 and comparing it to 5 over 6, the problem here is that as we look at the top numbers, we say, okay, well, the 5 is bigger than the 3, but the 6 is bigger than the 4. And we understand that from our earlier video on fractions and understanding fractions that we are slicing our whole, in this case, in this situation, we're slicing our whole into more parts than in this. And so that says that each part here is smaller than each part here. However, we're taking more of those parts when we take 5 out of the 6 compared to 3 out of the 4. So the big question is, which is winning out? Which represents the greater portion? Let me say that the question might be a little bit easier if we were comparing, say, 3 out of 6 to 4 out of 6. That would be easy, in fact, because with the slices, or the denominator being the same, both objects are sliced into 6 equal parts, we can see that 3 is less than 4, so 3 over 6 must be less than 4 over 6. But that's not our situation here. So I'm going to come at this two ways. I'm going to return to this because this is very important to us. But I'm going to come at answering this question, 3 over 4 compared to 5 over 6, with a diagram, just to give you an idea of what we're talking about. In our diagram, we have a circle that's sliced into 4 equal parts and another circle sliced into 6 equal parts. You can see that each of the 4 parts here are, in fact, each one is larger than each of the 6 parts here. So if this were a pizza, for example, and you know I like to talk in pizzas, one of these slices is larger than one of these slices. So let's continue with that pizza idea. If I'm going to look at 3/4, I'm talking about, say, taking 3 out of the 4 pizza slices. So this is 1, 2, 3 out of the 4. Whereas the 5 out of 6 looks like this. 1, 2, 3, 4, 5. Now, if you were to overlay the two diagrams, I think you could see that the shaded region in the right-hand circle is greater than the shaded region in the left-hand circle. And in fact, the one piece that's left off in each case, in the pizza sliced into 6, that leftover piece is smaller than the piece that's left behind in the pizza that is sliced into 4 parts. So this shaded region must be less than this shaded region. In other words, we would say that 3 over 4 is less than 5 over 6. Now let's come back to the idea of trying to do this question where perhaps we could compare two fractions with the same denominator. I'm going to re-slice those pizzas up top. And when I say re-slice, it's going to look something like this, where my new pizza on the left is going to be sliced into 12 parts. In other words, I'm going to take 3 over 4 and make it something equivalent out of 12. Well, when I look at this, I say the 4 can be converted to a 12 by multiplication of 3. Well, I will do the same to the numerator. I'll multiply by 3. And that leaves me with 9 over 12. So if I were to shade, it would look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 out of 12 shaded. Well, that was the same as the 3 out of 12 that were shaded up here. The slices are bigger in the top diagram, but they represent the same portion of the overall circle. So let's try the same with the 5 over 6. So I'm going to try and write that 5 over 6 as a fraction with the same denominator. So a denominator of 12. So here's what we'll do. We'll say to ourselves, okay, 6, to turn that into 12, we multiply by 2. We must also multiply the 5 by 2. So multiplying that by 2, we get 10 out of 12. And so that represents 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 12, compared to the 9 out of 12. So that just shows that the fractions 3 over 4 and 5 over 6 can be compared with the same denominator in a really easy way. We know that 9 is less than 10, so 9 over 12 is less than 10 over 12, so we conclude that the 3 over the 4 is less than 5 over 6. And if you really wanted to get fancy, you could say by 1/12. 5 over 6 is 1/12 more. And that's going to be our strategy for fractions when the denominators get a little bit strange. The 3 over 4 and the 5 over 6, you probably were able to reason out anyway which one was larger and which one was smaller, but it gets a little more difficult when I give you a question, say like this. So now I'm asking you, which fraction is greater, 19 over 30 or 53 over 84? Well, if you try and picture that in your mind, first off, you don't want to try and take a circle and slice it into 30 equal parts and shade 19, and another one it's sliced into 84 parts and shade 53. First off, it's difficult to slice in that many parts with all the parts being equal, and then by the time you've shaded them, they look almost the same. So we have to have another strategy, and our strategy is to find that common denominator. So let's take a look at the two fractions. So we'll start with the 19 over 30. Now the first thing I do in order to find a common denominator is I look for the lowest common multiple of 30 and 84. And from previous videos you would know that my strategy is to look at 30 and break it into its prime factors. So 30 splits down to be 6 times 5, which further divides down to be 2 times 3 times that 5. So I'm going to start by writing this denominator as a 2 times a 3 times a 5, and the numerator to be 19. Next, I move on to the 53 over 84. Once again, I will split up that denominator into its prime factors, so I'll do the prime factorization of 84. I need two numbers that multiply to give me 84. I know those to be, well, I could use 2 and 42, but I'm going to be a little more ambitious. I'm going to say 14 and 6. 14 divides to be 7, and 2 multiplied together. And 6 multiplies to be, or factors to be 3 and 2 multiplied together. So I'm going to write this denominator as 7 times 2 times 3 times 2. And my numerator is 53. Now it's just a matter of making sure that both denominators have the same factors in them. So this denominator has a 2, a 3, and a 5. This denominator has a 7, a 2, a 3, and a 2. Well, this denominator is missing a 5 that appears in this denominator. So I will put a 5 in that denominator and a 5 in this numerator. So I'm multiplying top and bottom by 5. Similarly, when I look at this denominator, it has an extra 7 and an extra 2 as factors. So I need to put in a factor of 7 and a factor of 2 in this denominator, and I do it both top and bottom. Well, now, when I go ahead and multiply all the numbers in the denominator, I get 2 times 3 times 5 times 7 times 2. That works out to 420. So both denominators are now the same, and they are 420. Now, when I multiply the numerator, the 19 times 7 times 2 of the first fraction, I get 266. Whereas in the second fraction, when I multiply 53 times 5, I get 265. Now, when you look at the two fractions with the same denominators, you can now compare the numerators. So the 266 is just slightly greater than the 265. So we can see that now the fractions can be compared pretty clearly, whereas before it was a little more difficult. And so based on these two fractions with the same denominator, the 266 exceeds the 265, so we can say the 19 over 30, 19/30ths, is a fraction which has a greater value than the 53 over 84. And so that's our most reliable strategy going forward, which is finding a common denominator for the two fractions and then just comparing the numerators. Essentially, that's all there is to it, and I'm out of time.